So I've been working on a water filter system that's portable and able to filter water from swimming pools, either saltwater or chlorine. So I've done a lot of research and a lot of testing. Started on this about 3 months ago. Thought it was going to be a lot quicker process, but there's a lot to learn, and went through a lot of testing different components of filters and pumps and gauges and valves and different things to basically make it work right. um, so to filter water from like a saltwater pool, basically to get salt out of water, you have to use reverse osmosis. There are also 3 different types of reverse osmosis filters or membranes. And you have your tap water membranes, you have brackish water membranes, and you have seawater membranes. So most of your houses run off tap water membranes. So the filter membrane that you use for like a saltwater pool would be considered a brackish water membrane. So anyway, so that's what we've got on our system is a brackish water membrane. And the other thing that I did with this system is you don't always want to, not all the water that you filter, you're going to want to put 2 or 3 gallons of wastewater for every gallon you get. Run into situations where you have water from maybe like groundwater from like a well, or rainwater, or even the water barrels sitting in your garage if they've sat there for 5 or 10 years. It's good to run that through something to make sure that it's nice and clean. And so what I wanted to design with this filter is not only to be able to have reverse osmosis to where you could filter water from swimming pools, Virgin River, but also to where you could take other water sources like rainwater or water in your barrels and be able to filter those through a filter that wouldn't have any wastewater. And what we've done with that is I've put a UF filter, which is ultrafiltration. But so, there's a couple things to look at when you're filtering water and filtering from a swimming pool. And that was kind of the main purpose for this, is reverse osmosis membrane does not like chlorine. So we basically have to get the chlorine out of the water before we run it through the RO. The other thing to look at too is when we get to the point where there's no power, no water, and you need to take water from your swimming pool, most likely at that point, most of the chlorine will have dissipated and you'll be dealing with bacteria at that point. But the reverse osmosis takes care of the bacteria. And even at that point, it could be run through the UF, but just to get rid of the rest of the little pool chemicals, the RO is best for that. So the other thing that we're kind of taking in consideration in building this system is if it comes to the point where we don't have water, most likely we're not going to have power either. So this system does run off 120 volt, and we really recommend buying a solar generator. You can get them off Amazon. Like the one we have over here is the EcoFlow. I can put a link to it in the description. They're a good brand. They've got great customer service. I can throw a little bit more about solar and solar batteries, power stations, kind of at the end of this, but just kind of continue on about the filter. So I'll show you the back side of this filter. So the water path on this filter is through an accumulator tank, which is basically a pulsation dampener. First stage is we have a 1 micron sediment filter, which basically just gets all your really big stuff like sand, dirt, just various things that are what you might consider just large items. Next, we have a activated carbon block carbon filter. And actually both of these filters, we have two carbon filters. One's a CTO carbon filter, the other is ACB. So carbon filters will pull something like your heavy metals, pesticides, and chlorine. So that's kind of one of the big things with the pool filtration is our two different carbon filters being able to pull that chlorine out before it gets to the reverse osmosis. So after it passes those three filters on the other side, then the water comes to this side and it will either pass through the UF filter and out this faucet, or it will pass through the reverse osmosis membrane and a remineralizer and out this line, and that's controlled with this valve here. This dial can adjust the pressure of the reverse osmosis. So we run this membrane at about 100 psi. The membrane is designed for a 220 gallon per day, but that a few things can affect that production rate. And so like the colder the temperature your water is, the lower production you get. Also, the higher the TDS in your water, that will also slow the production rate. So, but with some of our tests, you can figure about 150 gallons a day, which kind of sounds like a lot, but that's over a 24-hour period. That's just kind of how they're rated. So basically, you're going to be about roughly, depending on temperature and TDS, different things, roughly about 8 minutes to get a gallon of water. So if you were getting, say, 6 gallons an hour, you could kind of use that as a better gauge of sort of a little more practical. So if you as a family, if you needed to produce water and you needed 5 or 6 gallons in a day, you could do that in about an hour with this system. Okay, I'll just show you real quick kind of how it works. Our intake water comes in over here. This line here is where our wastewater will go out for the RO. And so this hose here is one that can be used if you're running through the UF filter. The other thing that we've done with this is we also have another faucet here, which can be just a water transfer pump. So if you had some water you wanted to pump just from, say, one barrel to another, and didn't want to filter it, you could hook up this hose to the transfer and basically just pump from one source to another. So it's kind of a little three-purpose system: transfer pump, UF filter, and reverse osmosis filter. So, and then this water line here is where our reverse osmosis water would come out. Okay, just to show you real quick how this works, we'll go ahead and turn this on. So this is our intake water. This bucket will be our wastewater from the RO, which nothing's going to come out of that if we're running through the UF filter, but if we're running through the RO, it'll go in there. And then here's our reverse osmosis line, our UF filter line. So the nice thing about these power stations is it will tell you the percentage of battery life you have left. And when you're running a device, it will tell you how many watts it's drawing, and it'll tell you how long you can run that device at the current rate. And once valves are shut off, the pump will run up to about 120 psi and just shut off. So then you can just turn faucet on, like UF water, and then we'll turn on the reverse osmosis water. Okay, so just quick up close of it running. Right now it's running, producing reverse osmosis water. See on our battery is at 89%. It's drawing 39 watts. And so at that rate, this battery could run for 16 hours. So over here, our reverse osmosis showing on. This is our adjuster gauge. Right now it's running about 100 PSI. That's how it works. Another quick thing to keep in mind is you probably wouldn't want to get one of these and take it camping and let it sit in your garage for like 6 months because there is water in the system. Sitting water is susceptible to changing, to growing bacteria and different things. And so with reverse osmosis membranes, they have different storage methods for them, like treating them with different things, taking them out. But my anticipation would be is if you were to use this in an emergency situation, that after you were done, that you would take the membranes out, filters out, kind of let the system dry out, and then use new membranes and filters then down the road.